So we can decide to factor out a e raised power of ax. And now here in this case, we should have y prime equals to a e raised to the power of ax is common to the two terms we have here. Then whatever we have left should be cos of ax plus b, then plus sine of ax plus b. Now, since we already have this, we need to apply one particular trig identity which says that if you have cos x, then this is actually equivalent. If I want to express, I have cos plus sine, but in trig identity, addition of trig, you can only have sine plus sine and only cos plus cos, or sine minus sine, then cos minus sine. So cos minus cos, rather, they must be the same. But here in this case, they are not the same. So what can you do to make sure that if you have sine here, I also have sine here? So I want to have sine sine. Okay, I want to have sine sine. Now, for me to transform this cos ax plus b back to what? Sine, then I'll quickly use this identity which says that if you have cos x, it's actually equivalent to sine of when you increase this x by 90. Okay, that's x plus what? Plus 90. Let's just confirm. Suppose you have cos of 40, let's say 60. Cos 60. Now let's look at this. Class, what is cos 60? Cos 60 is 1 over 2. Is it equivalent to when I try to do sine of 60 plus 90? I got 1 over 2 for cos 60, so let's try sine of 60 plus 90. Trivially speaking, you see, you also have 1 over 2. So this is allowed. So it's just like saying if you have cos of ax plus b, it is equivalent to this. When you have, if I want to transform this cos to sine now, that will be sine of the whole of this thing represent the function x that I've already represented there, the whole of it. Then just increase it by what? 90. And instead of using 90, mathematically speaking, we don't like using 90. We can just use pi over 2, where pi is 180 degrees. So I prefer to use pi over 2 for my expression. Okay? So just increase it by what? Pi over 2. This and this are still the same thing. Okay? Then plus what? Sine of what? Ax plus b. So you have to be very strong in trigonometry. So you need it in this case. Now, since you already have sine, so there's another identity that says that whenever you have sine c plus sine d. I hope you still remember this. That's math 111, trigonometric. Then this thing simply implies that when you have sine plus sine, the final result should give you twice, okay, of what? Is going to give you twice of that will be sine times cos, yeah. Twice of sine of c plus d over 2, then times cos of what? C minus d over 2. You all agree with this identity. So that's what I'm going to use in this case. So here in this case, I should have y prime equals to, this is representing c and this represents my d. So here I'm going to have a e ax. So when I sum this together by the rule of by trig identity, I will end up having twice of what? Twice of what? Sine of adding this and this together, c plus d. When you add the whole of this and this together, ax plus ax, that's 2ax, right? And b plus b, that's 2b. That means 2 is common, then I have ax plus b, twice of ax plus b. So then plus pi over 2 plus 0, then that will be just plus pi over 2. Remember that I will still have to divide the addition by what? By 2. So you divide this by what? By 2. So then, followed by a product of what? Cos. Then I will go ahead and subtract. On subtracting, ax minus ax cancel, b minus b cancel. What I have left is just plus pi over 2 minus nothing. That's what? Pi over 2. On subtracting, I have c minus d, I have pi over 2. Then divided by what? Divided by what? The 2 I have there. So then this is what I have. So we can still simplify this further by saying I'm still on first derivative. I've not done the second derivative. So the next thing will be 2 move outside. These 2 move outside. And then okay, don't let me rush you. So let's just take it one by one. 2a. The 2 is outside and I have ax. So whatever I have left now is sine of, I can split this up. When you have c plus d over 2, that will be c over 2 plus d over 2 separately. So that means this cancel this, then I will be left with just ax plus b. Then pi over 2 divided by 2, that will be pi over what? 4. Do you understand that? So that's how it works. Then whatever I have left here should be cos of what? Pi over 4. Pi over 2 divided by 2, that's pi over 4. So this is equivalent to, what is constant? I noticed that cos of pi over 4 is constant. So cos of pi over 4 can come outside from the bracket, such that I will end up having 2 is here. That's 2. Then I'll have cos of pi over 4. Then followed by this a and exponential of what? Ax. So whatever I have left now is what? Sine of ax plus b plus pi over 4. Do you understand that? And trivially speaking, cos of pi over 4 simply implies cos of 180 divided by 4. And 180 divided by 4, that is 45. Yeah. 180 divided by 4, that's 45. So what is cos of 45? The result gives root 2 over 2. So cos pi over 4 is square root of 2 over 2. Cos pi over 4 is square root of 2 over 2. And now I would just prefer we leave it like that so that we'll be able to generalize. I have a reason for that. So if I've done that, I will not be able to. It might work, but let's just leave it as cos. Since it is not affecting, if I'm trying to differentiate, I'll just leave it. The whole of this is constant. So whatever I have left now is just e of ax sine of ax plus b plus pi over 4. So, guys, this is constant, this is constant, this is constant. Whatever I want to differentiate twice now will be this. So I want to differentiate this thing again. So my second derivative, which is y prime prime. Okay, let me just try to put a mark here and then divide this. So y prime prime, which is the second derivative, simply implies this is here. I already have, okay, let me write 2a here, 2a of cos of pi over 4. So whatever I want to do now is differentiate this thing. That's uv prime plus vu prime. What would that give us? What is my u? U is exponential raised power of ax. V prime means differentiate this expression I have here. When I differentiate this, I will end up having a cos. Differentiate this one, I have a. Differentiate this sign, that's cos. Repeat everything back, that's ax plus b plus pi over 4. Right? Then that is for uv prime. Then plus the v I have, v is what? Sine of ax plus b plus pi over 4. Then times u prime. U prime means differentiate eax. That is a e raised power of ax. You all agree with this? So in addition, in continuation, we have this. Okay, as you can see, we end up having my second derivative to be equals to 2a cos pi over 4. What I notice now is that a is common, aeax is common, aeax is common. So dot aeax is common, right? So whatever we have left should be cos of ax plus b. Can you see that? Then plus pi over 4. Finally with what? Plus sine of ax plus b plus pi over 4, right? So that's how it works. Finally, we end up having my second derivative to be equals to 2a times a, that's 2a squared cos pi over 4 e of ax. So we have to do the same thing we have just done earlier. That is, I have cos plus sine. There is no trig identity that I have that kind of expression. So, but I have a trig identity of this expression, which is sine plus sine. So I have to transform this thing back to what? Sine. That will be, if I want to convert, if I want to express cos, this cos of this expression in terms of sine, okay, cos becomes sine. Automatically speaking, all this expression, which is ax plus b plus pi over 4, must be added with what? 90 degrees, which is what? Pi over 2. So have I made myself clear? So that's the best explanation I could give you based on that. So then, I don't need to, I'll just leave this the way it is. This does not have any effect. Let's just leave this. Since we already have, our own main target is to have sine plus sine. So then I can easily apply my my trig identity, which says that whenever you have sine C plus sine D, the result is twice of sine of the addition of this function that you have here. Add this and this together. That's on adding, okay, what's pi over 4 plus pi over 2? Okay, let's just go ahead and add sum the two together. This ax plus ax plus, that's twice of ax plus b, right? So then pi over 4 plus pi over 2 plus pi over 4, this simply implies that I have 1 over 4 plus 1 over 2, then plus another 1 over 4. I end up having just pi. That's plus pi, okay, on adding this and this together. Then that is sine c plus d. This is c plus d. After adding, then divided by 2. Using the identity, remember now. So that this c plus d, divided by 2. So then multiplied by cosine of the subtraction over 2. When I subtract this and this together, this cancel this cancel this. Pi over 4 will cancel pi over 4. Whatever I have left should be pi over 2, then divided by 2. Right? So the next thing for us to do here now is to try to factor out something reasonable. Y prime prime will be, so now I have 2. I'll prefer to write 2 square. That's the best thing to do. 2 square. So I'll be able to generalize. When I have 2, I have 2. So that's why I'm not trying to divide. Do you see that clearly now? So now here in this case, I have a square. And earlier before, I already have cos of pi over 4. So it's making sense. Now I still have cos pi over 4. So when this cos pi, pi over 2 by 2, that's pi over 4. When this multiply this one that is outside, I'll end up having all squared also. So I have square, square, square. So it's making sense. I'm already seeing the pattern. So then whatever I have left now should be sine of, when I separate this one, I have 2 cancel 2, and I have ax plus b, followed by plus pi over 2. So this is what I'm going to have, right? So what have you actually noticed from the first and the second derivative? For the first one, I have just power of 1, power of 1, power of 1 with EAX and pi over 4. The second one, I have their squares with EAX sine. From pi over 4, it reduced to pi over 2. I'm very sure by the time I do the next one, I will end up having just pi. And I'll have 2 cube, a cube, cos pi over 4 cube. Then you understand that. So it's preferred. I have to show it in this video so that I'm very, very sure that it works. So I have to differentiate this thing again. Find the third one, and then I'll guess for the fourth one. Okay. So let's proceed. This is for the second derivative, right? Now for the third one, for the third derivative, all this can be rewritten as, okay, let me leave it as 2 square a square cos of pi over 4, cos square of pi over 4. Either you want it all square. Now whatever I want to do now is to differentiate this. Call this one my u and call the whole of this my v. So then I'm trying to use product rule, uv prime plus vu prime, right? So my u is EAX. My v prime means differentiate this thing I have here. When I differentiate this, I will end up having a cos a abi cos the whole of this expression. I hope you all agree with that. Then plus v is the whole of this sine function that I have here. Ax plus b plus pi over 2. Then times u prime means differentiate that one, that is EAX. So by the time I factor out something reasonable, I have a, e, as common to the two of them. So when a come outside, I will end up having a cube, right? I have 2 square. When this a, e, okay, the a will multiply this one. The a that is common will multiply this a square, giving us, okay, don't let me convince you. So let me just write out on my own, step by step. Let's take it step by step. So what's common here? AEAX is common. Do you understand that? So whatever I have left is cos of ax plus b plus pi over 2. Next is sine of ax plus b plus pi over 2, right? So then y, the third derivative will now be 2 square, a square multiplied by a, that's a cube. Then I have what? Cos of pi over 4 square. So I really have 3 here. I'm very sure 2 is still coming outside from here, and this expression is still coming outside from here to get 3 cube for the 2 results. So then I have EAX here. So you know the next step to take now. I used to say that you have to transform this cos back to sine, and that would be sine of the whole of this expression you have here, but you must add what? You must add another pi over 2 to it, plus 90 degrees. Here you go. So then I have sine of ax plus b plus pi over 2. So then the next thing to do here is to apply the trig identity, the addition formula, which says that, I'm coming, let me write this out, square e of ax. So the addition formula of trig that says that whenever you have sine plus sine, you end up having, when you add this together, I think product formula leads to something like this. So that's not a problem. So that should be twice of sine of adding these two together. When I add the two of them together, ax plus b, that's twice of ax plus b. Then pi over 2 plus pi over 2 plus another pi over 2. That should be 3 over 2. I'm not really sure of that. 1 plus 1 over 2 plus 1 over 2 plus 1 over 2. Yeah, I'm correct. That's 3 over 2. Plus, so when I add this and this together, I have 3 over 2. Okay? And then 3 pi over 2 rather. That's 3 pi over 2 on adding. Then all divided by what? 2, right? So then followed by cos, multiply by cos of the subtraction. Subtract them, I have this cancel this cancel this. So I'll be left just pi over 2, then divided by 2. You see, this is still coming outside to multiply this. So then the next thing for us to do from here is to go ahead and simplify or factor out something nice. So the third derivative will be 2 here, multiply this 2 here, I have 2 cube, followed by a cube, then I have cos pi over 4. You know this is also cos pi over 4. Then when it's multiplied, I will also have cos pi over 4 raised to the power of 3. EAX is common. So whatever I have left now is sine. The only thing I have left now is sine of, if this cancels this, I have ax plus b. And at the same time, I have 3 pi over 2, then divided by 2. That should be positive of what? 3 pi over 4. Right? This is what I have. So from our guess, from the guess we have earlier, it is not following up. The first one was pi over 4. The second one was what? Pi over 2. Now here in this case we are having 3 pi over 4. So that means from our initial guess, it is not correct. From our initial guess, where I actually said that the next one should be just, the first one was pi over 4, next one is pi over 2. Then I said the next one should be just pi, which is not meant to be so. So here in this case, it is clearly seen that we have 3 pi over 4. So we can't just easily detect what will be the next one. Okay, I have not seen the pattern yet. So, but I also guess that the next one, which is y4, that's why I say you have to get it up to the fourth term before you could generalize. Okay, that's best way to do it. And then to guess, I can easily tell you that what if I guess that, okay, the next one for the y4 will be 2 raised to the power of 4, a4, this raised to the power of 4, and these, then sine of ax plus b plus, I'm very sure it should be 5 pi over, possibly over 4, but I'm not really sure. Let's try to confirm that. So for the fourth derivative, I have to prove for the fourth one. So I can't just guess what will be the fourth one. So this is for the third one. Now for the fourth derivative, which is y4. Y4 is, repeat what I have here, which is 2 raised to the power of 3, a raised to the power of 3, cos of pi over 4 raised to the power of 3, then e raised to the power of, sorry, I need to differentiate. So I need to differentiate this thing that I have here. Now this is u, then v prime means to differentiate this one, which is what? A cos ax plus b plus 3 pi over 4. Then plus my v, which is the sine function I have up there, 3 over 4. Then times, when you differentiate the exponential function, which is aeax. I hope you understand this. So I'm still following the same process. So next thing to do from here is that we have y4, the fourth derivative, to be 3 raised to the power of 3, a3 cos of pi over 4 raised to the power of 3. What is common? AEAX is common. So whatever I have left now is cos of AX plus B plus 3 pi over 4, then with a sine function above that I have up there, 3 pi over 4. So you know what to do from here. Transform this cos back to sine function such that we have okay, cos pi over 4 is power of 3 AEAX, such that we have this cos transferred back to sine function, and then I'll sum this thing with what? Pi over 2. And that will be AX plus B plus 3 pi over 4 plus pi over 2. Okay? Then finally, with a positive sign of sine, a k of AX plus B. I don't have any issue with this. So by the time we multiply a cube and a together, we have a raised to the power of 4. This remains the same, and I have EAX. So therefore, the sine function I have here plus this sine function I have here implies the trig identity, which will lead to product formula, and that is twice of sine of adding these two expressions together. So when I add ax plus b plus as plus b, when I sum them together, I will end up having twice of that result. And then by the time I sum up 3 over 4, 1 over 2, and 3 over 4, then that should be 6 over 4 plus 1 over 2, 3 over 4 plus 1 over 2 plus 3 over 4. So what I'm actually doing is I'm trying to add this, and this together to get 2. So it gives me 2. Wow. This thing is changing, as in it is changing. Okay, 3 over 4 plus 1 over 2 plus 3 over 4. I end up having just 2. That's 2 pi. When you sum everything together, you have 2 plus 2 pi. This, and this. Sum everything together, you have this. Then divided by what? Divided by 2. So the next thing for us to do now is to multiply it by cos of the subtraction. When I subtract this, whatever I have left is still pi over 2, then divided by 2. So we are able to generate, but this term I have here is quite different, but I'll try to generalize it at the end of the day. I think this is okay enough. I should be able to generalize from y4, or even though from y3, if you are very good in that. And then the next thing for us to do here is to have y4 equals 2 times 2 cube, that is 2 raised to the power of 4, a raised to the power of 4, this times this, that is cos pi over 4 all raised to the power of 4, right? Then e raised to the power of x. So whatever I have left now is sine of this cancel, 2 cancel 2, I have ax plus b left. Then the pi I was actually talking about is what I have left here now, just pi. 2 cancel 2. Guys, this is where I stop. So who knows what the next thing will be? The y5. So you can't easily detect, but let's just try to generalize. I think I should be able to generalize from here up to this extent. But to generalize the pi that is changing is the problem now. So I'll try to look into that. So to generalize, so let's pick it from here. We have to recall. This is where I stop for y4. This is the fourth derivative. So I'll recall all the derivatives that I've done so far. For the first derivative, recall that the first derivative we have, which is y prime, the y prime I have, so I'm trying to look for it. Where is it? Okay, I have it here. Y prime. Do you see that? So the y prime I have, recall that we have our y prime to be equals to 2 cos pi over 4, 2a rather, 2a cos pi over 4, right? All raised to the power of 1. Do you understand that? So that's the way I want it. E is power of ax, then I have sine of ax plus b plus pi over 4. That's for the first derivative. So then we also go ahead and we try to generate the second derivative, and the result is here. As you can see, the second derivative, which is y prime prime, the result is square square square, so I can easily factor it as 2a then cos pi over 4 all raised to the power of 2, right? Then I have eax of sine of ax plus b. Now in this case I have pi over 2, right? Then the third derivative, see it here. The third derivative gave us, we are able to generate this to as the y3 is y1. So the y3 we got was 2a cos pi over 4 all raised to the power of 3. Okay, then I have eax of sine of ax plus b. Then here I have 3 pi over 4. So the thing still baffles me. It is quite changing. This is changing, but I can easily generalize this one. So then the fourth one, the fourth result, as you can see, the y4, which is the fourth derivative, we end up having 2a cos pi over 4 all raised to the power of 4 eax, right? Then sine of ax plus b plus pi. Now the final thing we need to do from here is to generalize. So I'm not trying to, so I said I will not do for the y5. You can try the y5 out, but let's check whether we can easily generalize. When I generalize this, when you keep on differentiating up to nth time rather, that's the nth derivative for y, then I can easily tell you that when I have 1, I have 1. When I have second derivative, I have 2. 3, I have 3. 4, I have 4. And I can easily tell you that I have 2a cos pi over 4 raised to the power of what? 4, 4, that will be raised to the power of n, which is fixed. Then eax, then sine of all this remain the same, ax plus b. But now the problem is we need to find a generalized term for all this expression. Pi over 4, when I have 1, I have pi over 4. When I have 2, and it's making sense. What if I say when I have 1, I have n pi over 4? When I have 2, I have 2 pi over 4. That's pi over 2, correct? When I have 3, that's 3, it's n pi, 3 pi over 4, correct? When I have 4, it is correct. So we don't have to, we have already seen the pattern itself. So the pattern is that we have, when I have 1, I have 1. When I have 2, I have 2. The 4 is fixed down there. The 4 is fixed there. When I have 3, I have 3. When I have 4, I have 4. 4 over 4, that's 1. So it's just like saying we have n pi over 4. So that's the generalized term. So guys, trivially speaking, when I try to find generalized format for this, I will end up having n pi over what? Over 4. Or you say n over 4 pi. So yeah, in this case, guys, we will end up having, we can write this as, recall that I actually told you that cos pi over 4. See, cos, that's cos 1 over 4. I think it was 1 over 2 we got. No, we got root 2 over 2. That was the result. Root 2 over 2. So hence, we end up having y of n, that's nth derivative for the function y given to us from the question, equals 2a cos pi over 4. Pi over 4 is root 2 over 2. Then that means 2 cancel 2. Whatever I have left is just a root 2. So I have root 2a, or you write it as a root 2. Okay? A root 2 raised to the power of what? N of e raised to the power of what? Ax of sine of ax plus b. This n pi over 4 now can be written as, pi over 4 is 45. You can write it as 45n, 45 degree of n. But the best way to write it is just n over 4 pi. So this gives the final nth derivative for the function y given to us. So guys, thank you very much. Thanks for watching. Please try to subscribe so that I'll be able to so that you'll be able to get notification on any of my new videos that I upload. So thank you.